Alrighty, so beaches and barrier islands today. Today we're going to learn that sand forms from both mechanical and chemical weathering of rocks, along with contributions from the remains of living organisms. We'll learn that rivers delivered the sand to the coast, and then waves shaped and reworked the sand deposits into beaches. We'll learn that most of the sand we see today was originally broken from mountains during the last ice age, which ended a little over 11,000 years ago, and that makes sand a limited resource. And we'll learn that barrier islands are always on the move. So we have to start with the origins of sand. If we're going to talk about beaches, we have to talk about where sand comes from. And sand is primarily material that was brought into the ocean by rivers and streams, and then redistributed along beaches by waves and currents. There are a couple of different steps in the formation of sand, and the first is mechanical weathering. This is also known as physical weathering, but I'm going to say mechanical. And this is where a piece of rock breaks into smaller pieces. And so you can see here, this is the parent rock, and it can be broken down by wind, rain, hail, ice, and then the process of heating and cooling or freezing. And what we get is we get rocks that are smaller pieces, but they have the same qualities as the original larger rock. So they're just, pebbles, right? So that's what mechanical weathering does. Then we get further weathering that breaks down these smaller rocks into some of their components, and this is known as chemical weathering. So chemical weathering is the erosion or disintegration of rocks that's caused by chemical reactions. And this generally happens when rocks are exposed to water and the substance is dissolved in water. And so this would be because of any sort of contact with water or contact with any sort of acids. And we get the following components. So we get minerals and nutrients, including things that can be dissolved in the water itself. We get iron and aluminum. We get silica, and iron, aluminum, and silica can form clays. We also get silt and then sand, which is made up mainly of the quartz that's found in the rocks. And so basically what I want you to know from this is that sand is one of the components that we get from chemical weathering. Also, chemical reactions proceed faster at warmer latitudes, which means all of our rocks that are being exposed to water in warmer environments are more likely to be broken down into sand and other components faster. So colder environments tend to keep pebbles and gravel around longer than warmer environments where these materials are broken down faster. And just a reminder, even though this says, how is soil made? The creation of soil happens through weathering, but sand is actually considered sediment, not soil, because it doesn't form in place. It has been formed and then transported and deposited on the beach. Some weathering can continue in place, but for the most part, sand has to be transferred to a location, has to be moved there. So we get different properties of sand, and I think that the Gulf is a really good place to see what kinds of beaches are possible with different qualities of sand. And so if you have visited some of the beaches along the Gulf of Mexico, some may stand out in that they are very, very pure white sand. It's really nice to be on these beaches because the sand is so reflective that it actually doesn't heat up very much in the sun, and so that's kind of a downside of the beach, is that it can burn your feet, but white sand beaches do a lot less of that. So you might ask, why is Alabama and the Florida Panhandle Gulf Coast sand so soft and white? And the reason is because it is essentially pure white quartz crystal. This is crystal that was originally broken from Appalachian mountain rocks and then washed down from the Appalachian Mountains. Rivers delivered the sand to the coast, and then again, waves shaped and reworked those sand deposits into beaches. The mechanical weathering has ground down the particles further from like wave action, for instance. And weaker particles were eventually ground into dust and disappeared from the beach. And all that's left is the hardest of the particles, and that includes quartz. And so essentially, eventually after everything is broken down, all you have left is quartz, and that's why we have these beautiful white sand beaches. So what we see is quartz crystal at its smallest broken down size. Some white sand beaches are also crushed up coral deposits, but that's not what we see when we're looking at Alabama's white sand beaches. Sand in the Gulf can take on many different colors. It's not all white sand. And here's an explanation where at least some of those colors come from. This doesn't explain all of the unique sand that's found around the world, but this at least explains most of it. So you might have darker than white sand that's darkened by these black specks, and these can either be minerals like magnetite that remain in the sand or fossilized material. So sometimes fossilized shells show up as black specks. Black sand beaches that have pure black sand come from eroded volcanic material, and so these would not necessarily be found in the Gulf of Mexico. These would be some types of things that you would find in like Iceland and Hawaii and areas that are actually active volcanoes. The brown hues that you see in sand that make it shades of brown and yellow come from iron and feldspar that are mixed with the quartz. So iron produces some of those reddish-brown tinges to the quartz, and then feldspar itself is a mineral that's brown. And then you might see some light pastel colors, and so for instance, this is sand from the Washington Oak State Park Beach on the east coast of Florida, just south of Jacksonville. You can see it's kind of orangey. So those light pastels like orange, pink, and yellow often come from crushed shells or coral. So if you've ever heard someone say that the Bahamas have pink sands, the reason that those sands might appear pink is because they have a lot of crushed coral and crushed shell in them to make them that color. You guys kind of intuitively know what a beach is, but I figured since I say it so many times, we might as well make it a term to define. So a beach is a pebbly or sandy shore, especially by the ocean, between high and low water marks. You can have beaches around lakes, but for the purposes of this course, we're talking about ocean beaches. So these are occurring between the high and low water marks. Sand moves around a lot on a beach, and so beaches can be eroded and built up and reworked by the waves, as I've mentioned. And some of these movements happen much more frequently and on a much shorter time scale than others. So for instance, there are some movements of sand that happen hourly or daily or on a weekly scale, and those are typically happening right around the beach edge. So close to the beach, the sand movement is an everyday affair. As waves move sand towards the beach, gravity and backwash often move it back again at the same rate, and so you get this kind of give and take where both of these movements kind of cancel each other out, and you don't really see a lot of movement of sand up onto the shore just from the wave action itself. However, you do have large waves that might occur monthly or weekly, maybe with storms or with enhancements from the tidal cycle. So maybe you have a really high tide and you get some really big waves that are moving large quantities of sand upwards towards the beach. And so in that case, you might actually get sand that's placed a little higher on the beach. And the next slide tells you what happens to that sand. So once the sand remains on the beach, if it remains there and dries out during low tide, it can be removed from the surf zone by winds. And once it's removed from the surf zone by winds, then it can no longer be reached by waves, and it becomes a more permanent fixture of the beach. As the wind brushes over a dried beach area, it actually will push sand uphill. So sand, I mean, you've probably been in an area where when the winds have kicked up some sand grains and pelted you in the face and you're like, oh, the sand hurts, right? So really strong winds can move sand grains pretty well. But for the most part, even light winds are able to move sand up an incline in a kind of jumping motion. This is called saltation. That's not a term that I'm going to expect you to know. That's why it's not underlined, but decided to throw it in there. So as sand grains are able to kind of jump up the shoreline, they actually accumulate and they build a tall mound called a dune, which is just simply defined as a mound of sand that's formed by winds, by these activity of the winds causing sand to move up the beach. And then if the particles move so far that they're on the side of the dune that's sheltered from the wind, they just stay there. So they can accumulate there. They're not moving around a whole lot. The wind's not acting upon them. And so in this manner, the sand is pumped out of the sea, dried, and moved by winds up into the upper beach to form dunes. And so this is a typical beach profile where you have dunes in the backshore area, and then in the foreshore you get some areas that are impacted by waves and tidal activity where the sand is constantly reworked in that surf zone. Beaches are actually pretty resilient. They are able to rebuild themselves and take quite a hit from even some pretty powerful storms and then work their way back into a beach form again. And so in this case, they can provide protection from the sea for more landward areas. In order to self-repair, a beach needs a few things. So after a storm, let's say a lot of the sand gets swept away from a lot of bad wave activity, bad winds that are eroding away that sand. So if the beach is going to self-repair, then it needs beach sand able to dry. It needs a sea wind to blow the sand inland. And it needs to have some place to store that sand in dunes. So that means that a beach can store sand and grow during years with good sea winds, few rains or storms, and a lot of sunshine. And this image here kind of shows you what factors lead to good years where a beach grows, and we consider those accretion years. So sea winds, few rains, few storms, much sunshine. And then erosion years would be just the opposite. So winds not coming from the sea, winds that are blowing the sand out to sea, a lot of rain, a lot of storms, and not very much sunshine. And then as the dunes grow up, what they do is the beach profile steepens. And so as dunes grow upwards, you're getting a steeper slope. And eventually you have less area of the beach that's wet and more area of the beach that's dry and in a dune form. When those dunes are not growing and healthy, you get a wider, broader beach with a lot of wet sand. So I mentioned that most of the sand that we see today actually has been formed in the last 10,000 years or so. And this has to do with the time period of the last ice age. And so the ice age has a lot to do with sand formation of the beaches, the sand that we see that is formed today. So ice sheets like glaciers are great at mechanical weathering. Glaciers can actually scrape away rock below them, and they deposit the broken down material that they scrape away wherever they end up melting. And then once that material is deposited, then it's subject to chemical weathering. But basically, the glaciers are a great way to break down rock from mountains. So much of the sand that we see today was originally broken down from mountains during the last ice age, and that ended a little over 11,000 years ago. And then there were a couple thousand years of chemical weathering, and the result is our current supply of sand, which has remained relatively constant since about 10,000 years ago. So the material that we are walking on when we go to the beach is broken down rocks that were originally broken off the mountain during the last ice age. And some critters, dead critters. Oh, I'm sorry, this is not supposed to say exploring essential fish habitat. This is supposed to say saving sand. And so under week 10, 15 in class, you're going to have an activity called Saving Sand, where you'll learn about why the world is running out of sand. And so go ahead and do that activity now. I'm going to give you guys, I'll give you 10 minutes, but you're probably going to need a little longer than that. So I will go ahead and check back in with you at 11 o'clock. All right, how are we doing? Anyone need more time? Good, okay. All right, so, in that assignment, you learned about how the world is actually running out of sand, because sand is a limiting resource. And, of course, you know this because most of the sand that you see today was formed during the last ice age. So until we have another ice age, there really won't be another great supply of sand. So you learned about some of the consequences of the world running out of sand, and the fact that there are actually gangs and like gang-related activity related to the illegal trade of sand, which when I learned about this about a year ago, just blew my mind. Of course, I know that this is, a limiting resource, but the fact that there can be kind of, like crazy, almost like drug trade related activity around something like sand. Yeah, exactly. It's so weird. Anyways, so I thought you guys might like to learn about that. Okay, so, we talked about where sand comes from, why it's so important, why it's limiting. Let's talk about, the formations of sand after it's been reworked by the waves and deposited in certain areas. Sand forms beaches. And so there are a bunch of different types of beaches. You can get beaches that aren't actually made of sand, but instead have pebbles and gravel that was deposited by glaciers and has not quite been weathered down chemically yet, at least not very much. And these are called shingle beaches. And typically they're found at cold latitudes, and that's because in these latitudes you have relatively slow rates of chemical weathering, of erosion of these pebbles as they're exposed to water. If we're talking about sand beaches, there are a variety of different forms that sand beaches can take. You can have one that's attached to the mainland. This is a typical beach that we think of that's fringing a larger landmass. You can have a beach that occurs as a barrier island, which would be a large sandy island lying parallel to shore. One that is an open side beach, which is in relatively open water. It's open to the full force of winds and waves. And these can also be mainland attached beaches that are open to, for instance, the full force of waves from the Atlantic Ocean. And then you can have sheltered beaches that are protected by the most powerful waves. And so, for instance, in your typical barrier island, you're going to have one side that's exposed to the full force of the winds and the waves coming towards that island, and that side is going to be the open side. And then on the other side of the barrier island, you're going to have a sheltered side that's protected from the powerful waves. And so you can see how these dichotomies exist even within a barrier island. I want to talk a little bit more about barrier islands because they're so important in the Gulf of Mexico, and they have a really unique way that they formed in the Gulf of Mexico. So a barrier island, a little bit more detail on the definition, is a thin, long island separated from the mainland by a bay, lagoon, or marsh. So separated from the mainland by a bay, lagoon, or marsh. And there are a couple of different ways that these form. And so in Louisiana, the formation is from retreating delta lobes. And so as these delta lobes grow out, once they're abandoned, the lobes will shrink away and leave behind the edges. And those edges become barrier islands. Eventually, all of the delta lobe is kind of shrunk away, and so all that's left is that island arc that was the shoreline of the delta lobe. And so this way that barrier islands form is very typical of Louisiana. This is how all of the closest barrier islands, Grand Isle for instance, formed. Then another way you can have barrier islands form is from retreating shorelines, just from sea level rise. And so, for instance, during the last ice age, when sea level was a lot lower, there were beaches that formed along the coastal plains at the time. Beach sand was piled up into large dunes that were situated parallel to shore. And then as sea level rise flooded the coastal plains, then those dune ridges actually were located offshore, and the tops of the dune ridges were sticking up above the waterline, and they became islands. And so this way of barrier island formation is very typical of the east coast of the United States, and very typical of a lot of coasts around the world. So most of the barrier islands that are not existing really close to a really big delta are going to be formed this second way from retreating shorelines. Excuse me. I breathed in my tea. That was dumb. Okay. Alright, so it's okay. I'll live. So I think that we're going to go over some of these concepts from this video, but I think that the way that barrier islands move is so interesting, and it's going to be a lot better if you can actually see it. And so I'm going to put this link, where is it? Here it is. Put this link in the chat box for you guys to watch this video. And then we'll go over some of the concepts that I want you to know after you watch it, so you don't have to take too careful of notes. So I will see you back. How long is this thing? I'll see you back in 5 minutes. You guys finished with the video? Awesome. Okay, so from that video, what I want you to know are, of course, the major point that he made is that barrier islands are always moving, and that is due to longshore drift, which for the purposes of this course we'll say means sand and water move down the beach due to the waves approaching the beach at an angle. And that means that barrier islands also move in the direction of longshore drift, and so barrier islands are moving. They're moving both laterally, like along the shore, and they're also moving inland, moving towards the shore because of overwash. Coastal landowners, of course, don't want sand to move. They have an interest in keeping their beaches where they are, the same width. In fact, many times they want to add to their beaches, and so what they'll do is they'll build structures to allow them to trap some of that longshore drift sediment. And so they'll build groins, which is a structure that extends perpendicular to the beach out into the surf, and the intent of these is to trap drifting sand, and so they'll trap sand from longshore drift. Bo has an alternative theory. Barrier islands are running away from sand mafias. It is certainly in their best interest to do so. I'm imagining a little comic of a little sand island with little googly eyes. It'd be so fun. Okay, so they'll build groins, and then also landowners near the coast will replenish the beach with sand, in what's known as beach replenishment, which involves pumping sand onto an eroding shoreline to widen the existing beach. And of course you learned that that's really expensive and that it doesn't last forever. So it's not a permanent solution. Heidi, stop. Stop. Go lay down. Go lay down. Go on. Her boyfriend is outside playing and she's not invited, so it's a really sad thing. Okay. Go lay down. It's class time. I've got a couple of quiz questions. Yeah, she's so cute. Are you cute? Yes, you are. I have a couple of quiz questions for you, and so we're going to end class on these quiz questions. So there are 2 of these. The first one is true or false. The building of one groin on the beach often leads to many other groins being built because a groin will cause sand to erode from one side of the structure. All right, you guys are on top of it today. All right, and the answer here is true. That's exactly true. That's what you learned in the video. The building of one groin might be great for the landowner that builds it because they're trapping sand from longshore drift, but sand is going to be eroded from the other side of the groin, and so their neighbor may then decide to build one too. And that continues. Second question. Which of the following is true about beach replenishment? There's only going to be one correct answer here. Hey, come here. Come here. Come say hi. Come here. Heidi. Heidi, come here. Come say hi. Sit down. Here she is. That's Heidi. Want to shake? Oh, yeah. Okay, you can't go outside and see your boyfriend, but you can at least meet my class. Alrighty. So, she's so good. She's such a good dog. She's beautiful. She's a German Shepherd Husky mix. Okay, so the answer here is actually A. So the sand that is used to replenish the beach is commonly gone in less than 4 years. It's actually a really expensive fix. So it's an expensive process to do beach replenishment. So B is not correct. C, it's not a natural process. Beach replenishment is actually something that humans will do. And D, the construction of breakwalls actually causes additional erosion of beaches. So the construction of breakwalls does not actually keep beach sand in place. It will cause erosion of beach sand. The construction of groins will keep beach sand in place. And the difference here is that groins are perpendicular to shore and they're going out into the surf, whereas breakwalls are parallel to shore. And so what you get is the sand that is next to the breakwall. It will be eroded over time and undermined. So this one is going to be A. And we'll wrap up. Today you learned that... Come here, Zeke. Come join us. This is my other doggy. Can't see him. There you go. There's my other doggy. Today you learned that sand forms from both mechanical and chemical weathering of rocks, along with contributions from living organisms. You learned that rivers deliver sand from the coast, waves shape and rework the sand deposits into beaches, and my dog shapes and reworks sand deposits on beaches. Most of the sand we see today was originally broken from mountains during the last ice age, which ended a little over 11,000 years ago. Don't hit my microphone. And barrier islands are always moving. And that's the end of class. So we'll leave it there. And I will see you guys on Wednesday and we'll talk about your final project. Oh! I had that coming. You're not supposed to wrestle. You're just supposed to say hi. I know. So needy. Look at that big doofy face. He's a big doof. You don't have to fight for attention. There's a lot of students. They'll all give you attention. Have a good one. See you guys later.